Thank you. I will hope you are still awake and I can talk about a new trait we developed last year in the Netherlands, and we call it calf survival during rearing. What is the current situation about a live cattle? Well, we have breeding values for survival around birth, called livability or stillbirth. And we know something about survival after first calving, the breeding value for longevity, so that is the productive life. So between stillbirth and starting the first lactation, there's a gap which we don't know much about. So that's what we call the survival in the rearing period. And we know it's economically important because when a calf dies, there are losses due to calf cost, labor cost, and housing cost, feeding costs, that kind of stuff. And it's important to monitor it, and that's possible with a genetic evaluation. So we can monitor it phenotypically and genetically. The aim of this talk is to show you the results of this new trait, calf survival, genetic parameters, and in a breeding value estimation setting. To show you how calf survival is performing in Holland or in the Netherlands, when are calves dying? Well, in the first 30 days there's a clear peak of calves that die, with a top of around 0.3% in the first 2 weeks. That's 0.3% per day. Then it decreases rapidly to, at 180 days, the percentage death is at a low level, and after that is at a real low level. And when heifers start calving, then culling is increasing again. But this is already taken care of in the breeding value for longevity. So which traits did we define? We did a research last year already, and we defined a major trait, the trait of interest, which is calf survival of replacement heifers in the first year of rearing. And we took the period from day 3 onwards until 1 year. The first day is still taken care of in the breeding value of stillbirth, and we skipped the second day of life because the data quality is not good enough. And then we also have 2 predictor traits we got from the research. The first trait is day 3 to 14. This is both for male and female calves, so we can handle all calves. And it's a good predictor. The second trait is the period from day 15 to day 180, and those are field calves. So those are calves that move to a specialized field farm. And for this trait we also can use the male and female calves, but in the Netherlands the major part are male calves. So we have those 3 traits, so we can do the data selection. We have data available since July 1993, because since that date or that year it was obliged to have the identification and registration system. So all calves are ear tagged by that date and registered in a national database. And obviously we need pedigree to handle it in the breeding value estimation. So the calf should be herd book registered. And it's also should be, the herd should be classified as a rearing herd or a specialized field herd. Because in our database we also have herds that are, slaughterhouses are also regarded as a herd, but we don't want that kind of data. So the number of data we end up with, for the first year of rearing we have almost 8 million records or observations with a survival rate of 94%, 94.4. For the second trait we end up with 17.5 million observations, with a survival rate of a bit more than 98% alive calves. And for the third trait, the field calf trait, we have 7.5 million traits with 97.5% survival. So in total, we have nearly 33 million records of 17.5 million animals. The model we used, it's a multi-trait linear animal model with 3 traits. The 3 traits I described previously. The effects in the model. For the first 2 traits, we have a herd year effect and a year-month effect. Whereas in the third trait, for the field calves, we have a herd times year times month effect. Because in the Netherlands, the field calves are at specialized field herds, which have several batches a year, and with this effect we can handle those batches separately as an effect. Other effect in the model for the 3 traits is the parity of the dam. Sex is only applicable in the third and the second trait, because the first trait is only female calves, so the sex effect is not necessary. Heterose and recombination are in the model as a covariate for all 3 traits, and animal effect for the genetic effect. Genetic parameters we got from the research. In bold are the heritabilities. So for the main trait, the heritability is 1.1%. It seems low, but the genetic standard deviation is 2.5%. So there's enough variation. Then the second trait and the third trait have a heritability of 0.6% and 0.5%. But the genetic correlation with the main trait is for the second trait is 0.85, so that's at a high level. So this is a good predictor. And because there's overlap between those 2 traits, there's an error correlation of 0.62. And for the third trait, it has a genetic correlation of 0.66 with the main trait. So there's also a good predictor. And the error correlations of the field calf trait with the other 2 traits are 0 because there's no overlap in data or there's no overlap in the animals. That's why the error correlation is 0. Some results. The effect of the parity of the dam. The higher the parity number is of the dam, there's more survival of the calves in the first year of rearing. And it goes up to 1.4%. So that's why it's included in the model. The effect of sex, it's there for the second and the third trait, as mentioned before, and it's 0.4 and 0.6%. So and that's the benefit of the female calf over the male calf. So female calves have a higher survival rate. The effect of heterosis, for the main trait, calves with 100% heterosis have a higher survival rate of 1.5%. For the second trait, it's only 0.2%. And for the field calf traits, it's 0.6%. The genetic trend of the cows, it's a pretty stable trend. It's within a range of 1% during a time frame of nearly 20 years. And the same is applicable for the genetic trend of the bulls. And this is logic because there has been no selection for this trait because it was not available. And presumably the genetic correlation with other traits is close to 0. How will the reliability of the bulls build up when progeny is coming in? I've 6 scenarios when only the second trait is available, so when the calves are just getting born and could have reached the age of 14 days. Reliability of the main trait will be at the level of 44%. And when those Field calves are also old enough, the first batch. Reliability will increase a bit to 46%. And when the young bull will end up with his first test period daughters, or all his test period daughters, which is at the level of 400 to 500 bulls in the Dutch situation, the reliability will be at the 62%. And this is still before the first daughters will be in production. So, and when the bulls are proven bulls, so heavily used, the reliability will rapidly increase to 70%, and in the end, on the heavily used bulls, to 98 or 99%. Here's a distribution of the breeding values for black and white bulls born since 1985 for the main trade. We see there's a normal distribution with some bulls at +3 standard deviation, and unluckily some bulls are -3 standard deviation. But still, we have some bulls have a standard deviation of 1 or higher, above average. This is 14%, and when those bulls will be used on average on average cows for calf survival, you can expect that calf survival rate will increase by at least 1%. So that's worthwhile to do. So I will end with some conclusions. A breeding value estimation for calf survival is possible based on there's more than enough data. We already have nearly 33 million records. Test bulls will have a reliability of 62%, which is at the same level of some other low heritable traits. Predictors contribute to the trait of interest. There's enough variation between bulls because genetic standard deviation is 2.5%. And for farmers, this trait could be of economic importance. So that's why we will implement or start publish breeding values probably next year, April. So thank you.